Base load requirement is the minimum level of demand on an electrical supply system over 24 hours. Base load power sources are those plants which can generate dependable power to consistently meet demand. They are the foundation of a sound electrical system. Description: baseload plant is an energy plant devoted to the production of baseload supply. Baseload plants are the production facilities used to meet some or all of a given region's continuous energy demand, and produce energy at a constant rate, usually at a low cost relative to other production facilities available to the system. Examples of baseload plants using non-renewable fuels include nuclear and coal-fired plants. Among the renewable energy sources, hydroelectric, geothermal, biogas, biomass, solar thermal with storage and ocean thermal energy conversion can provide baseload power. Baseload plants typically run at all times through the year except in the case of repairs or scheduled maintenance. Hydroelectric power also has the desirable attribute of dispatchability, but a hydroelectric plant may run low on its fuel if a long drought occurs over its drainage basin. Each baseload power plant on a grid is allotted a specific amount of the baseload power demand to handle. The baseload power is determined by the load duration curve of the system. For a typical power system, the rule of thumb is that the baseload power is usually 35 to 40% of the maximum load during the year. Peaks or spikes in customer power demand are handled by smaller and more responsive types of power plants called peaking power plants, typically powered with gas turbines. Whilst historically large power grids have had baseload power plant to exclusively meet the base load, there is no specific technical requirement for this to be so. The baseload can equally well be met by the appropriate quantity of intermittent power sources and peaking power plant. Economics: power plants are designated baseload based on their low-cost generation, efficiency and safety at rated output power levels. Baseload power plants do not change production to match power consumption demands since it is more economical to operate them at constant production levels. Use of higher-cost combined cycle plants or combustion turbines is thus minimized, and these plants can be cycled up and down to match more rapid fluctuations in consumption. Baseload generators, such as nuclear and coal, often have very high fixed costs, high plant load factor and very low marginal costs. On the other hand, peak load generators, such as natural gas, have low fixed costs, low plant load factor and high marginal costs. Typically baseload plants are large and provide a majority of the power used by a grid. Thus, they are more effective when used continuously to cover the power baseload required by the grid. Baseload power plant usage: nuclear power plants may take many hours, if not days, to change their power output, although modern stations, and those in France, can and do operate as load-following power plants and alter their output to meet varying demands. Nuclear and coal power plants have low fuel costs. Because they require a long period of time to heat up to operating temperature, these plants typically handle large amounts of baseload demand. Different plants and technologies may have differing capacities to increase or decrease output on demand. Nuclear plants are generally run at close to maximum output continuously, while coal-fired plants may be cycled over the course of a day to meet demand. Plants with multiple generating units may be used as a group to improve the fit with demand, by operating each unit as close to peak efficiency as possible. See also: capacity factor, energy demand management, grid energy storage, load balancing, smart grid, load-following power plant, peaking power plant. References. External links: baseload power plants, fundamentals of electricity, levelized costs of electricity production by technology, the Energy Resources and Economics Workbook.